Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Let's talk about the 6 trig functions. Now, you're watching this hopefully for an Algebra 2 class, or at least that's the playlist I'm putting it on in my channel. But if you're in Algebra 2, you probably recognize this, hopefully recognize this from geometry last year. Well, in geometry, we talk about these same trig ratios. We also talk about them here in Algebra 2. So the purpose of today's video is for us just to look at these 6 trig ratios, these 6 trig functions. We're not going to evaluate anything with them in this video. We'll do that in later videos, but we're just going to jump right into it, hopefully have a little bit of keys to memorizing what these ratios should be, and then we'll look at this diagram to help us figure it out as well. So we see on the left side of the screen we have our right triangle. So that's step number 1. We got to remember and understand that these ratios are for right triangles only. And so we see we have our angle down here, and one of our angles could easily be in our other acute angle. It's just not going to be in our right angle. So it doesn't matter which acute angle it's in. For this video, we've got it down here in the bottom left. So we see that we have a hypotenuse of the right triangle. We know the hypotenuse is always going to be opposite of our 90-degree angle or opposite of our right angle. Another way to think about it is it's the diagonal side of our right triangle. So we have the hypotenuse. Right? No questions there. Now the other two sides are named in relation to our angle. So here we have our theta, or our Greek letter, in our bottom left-hand angle, what we're looking at here on the screen. So we have two other sides. These would be considered the legs of the right triangle. One of the sides is opposite of theta, and the other one here is adjacent to theta. And so that's where those names come from, opposite and adjacent. And so once again, if theta were to be in, let's see if I can move it without moving my triangle. Okay, if theta happened to be up here, right, in this angle, then obviously those sides would be reversed. Now adjacent would be my vertical side, and opposite would be my horizontal side. Okay, well that's not the case, and so now this is what our diagram is going to look like. So we need to know those three terms: adjacent, opposite, and hypotenuse. Now we see our 6 trig ratios, or our 6 trig functions on the screen. We have number 1, or one of them is sine. Then we have cosine. Then we have tangent. Then we have what's called cosecant. We have secant. And we have cotangent. So I've listed them in the relationship that we see them, or in terms of like the inverse. So for sine, the inverse of sine would be cosecant. For cosine, the inverse of cosine would be secant. It's right below it. And for tangent, the inverse would be cotangent. So those are our 6 ratios, or our 6 functions that we can get from this right triangle. Now, let's talk about the ratios. Well, it has to do with the sides of the triangle, right? So for sine, sine is going to be opposite side over hypotenuse. So notice the abbreviation OPP, that stands for opposite, and HYP stands for hypotenuse. So to find the sine of theta, I would take my opposite side over my hypotenuse. That would form my ratio. Now for cosine, we're going to do the adjacent side over the hypotenuse. So now we see our abbreviation ADJ, and that stands for adjacent. So adjacent would be this measure over the hypotenuse. Okay, so now there's only one other ratio to go with, right? Well, we have now our tangent, and this is now going to be opposite over adjacent, okay? So we have sine, we have cosine, we have tangent. And so maybe in geometry you heard of a little acronym known as SOHCAHTOA. That is a great acronym to remember what the ratio should be. So it looks like this: SOHCAHTOA, right? And so what does that mean? Well, S, C, and T stand for our ratios, S, or for our trig functions, sine, cosine, and tangent. And then the O and the H and the A stands for opposite or adjacent or hypotenuse. So S-O-H, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. TOA, tangent, is opposite over adjacent. Now we do have these other 3 functions here at the bottom: cosecant, secant, and cotangent, and we mentioned that they are inverses. Well, all we need to do is switch the ratio. So if sine is opposite over hypotenuse, cosecant would be hypotenuse over opposite. If cosine is adjacent over hypotenuse, then secant would be hypotenuse over adjacent. And lastly, if tangent is opposite over adjacent, then cotangent would be adjacent over opposite. Okay, so those are our 6 trig functions and the ratios that represent them. Now we look here at the bottom, we could also rewrite cosecant, secant, and cotangent as 1 over sine, cosine, and tangent. So another way you might see cosecant represented is by saying it's 1 over sine of theta. Secant would be 1 over cosine of theta, and cotangent would be 1 over tangent of theta. Okay, so those are the 6 trigonometric functions. And like I said, we're not evaluating anything with them right now in this video, so check out the later videos after this one on my channel to see how we can use these ratios to figure out missing side lengths, later on missing angles, and other things like that for right triangles.